Hello, and welcome to a little video about comparing data sets. Alright, first let's talk about comparing mean and median. The reason we need to compare mean and median is to decide whether our data is skewed or symmetric. When we have symmetric data, our mean and median are about 1 unit apart. When we have data that is skewed, that means our mean is larger or smaller than the median by more than 1. When we're skewed right, the mean is larger than the median, and when we're skewed left, the mean is less than the median. Right and left have to do about the position of the mean on a number line when compared to the median. Depending on whether the data is skewed or symmetric, we use either the median or the mean as our measure of center. If the data is skewed, we use the median as our measure of center. If the data is symmetrical, we use the mean as our measure of center. So for number 1 and 2, let's decide which measure of center is the best for this data. So what that means we have to do is find the median and the mean and see how far apart they are. Okay, in number 1, I'm going to begin by finding the median by crossing the number off on each side. I got 58. Next, I'm going to find the mean by adding up all the numbers and dividing by the amount of numbers I have. So I'm adding 50 plus 53, 57, 58, 58, 59, and I click enter, and then I divide it by 7 because there are 7 numbers on our list. When I get my answer, I turn it into a decimal, and I got 56.29. If you take a look at the two numbers, 58 and 56.29, they are more than 1 unit apart. So for this data set, we will use a median because the data is skewed. Alright, let's do the same thing for number 2. First, let's find the median. We can still do that by crossing a number off on each end, 42. Next, let's find the mean by adding up all the numbers and dividing by 7, because that's how many numbers are on our list. This time we get a nice whole number. Whoops. It's 39. Once again, our data is skewed because the median and mean are more than 1 unit apart. So, use the median because the data is skewed. Okay. Now something that can skew a data pretty significantly is a number that kind of doesn't belong. So let's take a look at this little dot plot in number 3. We're going to do 2 things. We're going to calculate the mean of the whole data set, and then we're going to find the new mean, and I'll talk about that in a second, and then decide which one represents it better. Now when I say mean and new mean, in my original mean, we're just going to add everything up and divide by the amount of dots, and then we're going to delete one of the dots that doesn't belong. So take a look at this dot plot. Which one looks like it doesn't belong? The dot above 7. That doesn't fit with the data. And if you look at the data in general, it looks like our mean should be around 2-ish. And the reason I can make that guess is because we have the most dots in 2. So the probability of us having a 2, the average, I know it's not the same, but it looks like it's 2. So first let's do the mean with 7. So mean 1. I'm going to add up all the numbers. So each dot represents like how many times a 1 or a 2 happened. So this one is 5 1s. Then we have 8 2s, 3 3s, 2 4s, and a 7. So if I add up all those values, I get 45. and I have 19 dots. When I divide those, I get about 2.4. I think it's like 3.6, but I'm going to round it to 4 for this one. Next, I'm going to delete the 7 from our data and see how does that change our mean. So if we take out the number that doesn't fit, how does that change things? All right, mean 2. If I don't have the 7, I end up with 38 when I add everything up and 18 dots. When I do 38 divided by 18, I get 2.1. Just from looking at it, we could make an easy guess that the mean should be around 2. So which of these means represents that guess or the data a little better? It's mean 2. Just by looking at it, you can tell that the average is going to be 2. And when we calculate it, it gets even closer to 2 when we take away a number that doesn't fit. Let's talk about those numbers that don't fit and that could create such a difference between our means. Now I know here it's such a tiny difference, it's a 0.3 difference, but the larger numbers we deal with, the bigger the difference can be in the mean. These numbers are called outliers. They are numbers that are too big or too small for our data set. They don't fit. Numbers too big or too small for the data set. Now, sometimes they're going to be obvious, other times they will not be obvious. So we have a little formula for that. An outlier is typically calculated by multiplying the interquartile range by 1.5 and then determining if there are any data values lesser than the calculated distance from Q1 or Q3. So we have a lower fence and a higher fence, and here are the formulas for them. For the lower fence, we would plug in the first quartile and subtract IQR times 1.5, and if we have any number below that value, that's an outlier. Same goes for the upper fence. If we have anything larger than that, it's an outlier. So let's do that in number 3. In order to find Q1 and Q3, we need to find the median. The median in this data set is 16. So Q1 is the median of the lower end, so the smaller numbers. Q1 will be 15. Q3 is the median of the higher end of the numbers, 18. So we have almost everything we need for our formula. Next, we need the IQR. In order to find IQR, we do the third quartile minus the first. So that means our IQR, our interquartile range, is 3. Okay, so let's find, let's calculate the lower fence. Here is my formula. So we got LF. I'm going to circle that formula a little better. There it is. Okay. Q1 minus IQR times 1.5. Q1 is 15. Right, here it is. So we got 15 minus my IQR is 3. 3 times 1.5. When I plug that into my calculator, I get I get 10.5. Is there anything on our list that is smaller than 10.5? No, I do not. So there are no outliers on the lower end. Let's see if there's any outliers on the upper end, so the upper fence. The formula for the upper fence is, if it'll zoom out, there it is. It is Q3 plus IQR times 1.5. Okay. Well, Q3 is 18 minus the IQR, which is 3, times 1.5. When I plugged that into my calculator, I got, let me double check, yes, 22.5. Are there any numbers on our list that are larger than 22.5? Yes, it's 56. Let's do the same in number 4. Before we even consider the formulas, we need to rearrange our numbers from smallest to largest. This is important whenever you're looking for anything related to medians. All right, I have 6 numbers here. So that means my median will exist right there. I don't really need to calculate it because I don't need to use it right now. I do need Q1 and Q3, which is why I need to find the median. I just need to find its location. All right, the first quartile is 151, and the third is 193. Let's find our IQR by doing the third quartile minus the first. 193 minus 151 is 42. And we have all the information we need to plug it into our formulas. All right, lower fence. The formula for the lower fence starts with quartile 3, so 151, minus our IQR, 42, times 1.5. When I put that into my calculator, I get 88. Is there anything on this list that's smaller than 88? Yes, we have a 22. Just because we had a number lower than our lower fence does not mean we're going to have a number we're not going to have a number higher than our upper fence. So let's do our upper fence. The formula for upper fence starts with Q3, which is 193, minus our IQR, 42, times 1.5. Oh, plus. When I put this into my calculator, I get 256. Are there any numbers larger than 256 on my list? No. 22 is my only outlier. In number 5, we have to rearrange our numbers just like we did in number 4. Remember, you got to do that, especially when you're finding medians. And if it looks like I'm just looking at this list and writing down the numbers, that's not what's happening. I totally wrote these ahead of time because I thought it would save some video making time. Alright. There's our list. Make sure you have the same one if you're working on your own. Or pause it. The first thing we need to find here is the median. This is a long list, so let's cross things off. Let's find it. Let's find the number or location of the median. Oh, beautiful. 239. I don't need to use it. I just need to know where it is so that I don't use it. Okay. Q1 is 181 and Q3 is 257. Great. So we can find our IQR by doing 257 minus 181. which is 76. Okay, we officially have all the information that we need in order to find if there's an upper or lower fence. Now this data set was a little harder to see if there's an outlier and which one it is. So if you think it's 173, we'll prove it or disprove it with the lower fence. When I looked at this data, my guess was that there's going to be an upper fence and that 295 is going to be the outlier. So let's see if I was right. All right, lower fence. We start with Q1, so 181, minus our IQR times 1.5. When we plug this into our calculator, I get 67. Is there anything on our list that is smaller than 67? No. So there's no outliers on the lower end. All right. So far, so good. Let's see if I'm right about the upper end. So for the upper fence, we're going to do third quartile, so 257, plus the IQR, so 76, times 1.5. When I plug that into my calculator, I get 371. Do we have anything on our list that's larger than 371? No. There are no outliers. So clearly, past me was wrong. Now I know now that there's no outlier, but when we were doing these problems for the first time, I kind of like to predict and see if I can, guess it right. I didn't, but that's why we have our formulas. For the last problem for this section, we're going to choose the appropriate measure of centered spread. When we have data that is skewed, even one of the data sets is skewed, we need to use the median and IQR. If the data is symmetric, and it has to be both data sets, then we use the mean and standard deviation. All right. So in order to find out whether class A and class B are skewed or symmetric, we need to find their mean and median and compare them. So let's start with class A. Class A. Their median. Take a look at the list for class A. It's in order. What's the median there? It's 8. Next, let's find the mean. We get it by adding up all the numbers and dividing by the number of numbers. So after adding it, divide by 7, and you should get 9.57-ish. So you need to decide now, is this data skewed or symmetric? It's skewed. It is more than 1 apart. So 8 and 9 would have worked. 8.57 and 9.57 would have worked. But 8 and 9.57 is more than 1 apart. Okay? Now let's do the same for class B, because the question asks us for each data set. Alright. Easy peasy, let's find that median of class B. That would be 6. Then we find the mean by adding up all the numbers and dividing by the amount of numbers on that list. So that's 7. When you divide it, you should get around 6.7. This data is symmetric. It's symmetric because it's only 0.7 away from each other, 6 and 6.7. Now, unfortunately, because class A is skewed, we must use median and IQR. Only when both data sets are symmetric can we use mean and standard deviation. So let's write that down. We use median as the center, and IQR as the spread. Because one of the data sets is skewed. All right, that's the unit. If you have any questions, please let me know. Otherwise, have a wonderful rest of whatever day it is for you. Bye.